Hey everybody, now we're going to take a look at section F-2. We're going to look at a couple more properties here, a couple of theorems. One's called the perpendicular bisector theorem. Basically what it says is if you have a segment and you have a line cutting through it which is perpendicular and through the midpoint, in other words, the perpendicular bisector, then any point that's on this bisector will be equidistant from the endpoints of that segment. In other words, if we look over here, because PM is on the perpendicular bisector of AB, you can see it goes through M, which is the midpoint, and it is perpendicular. Therefore, AP is the same length as BP. So equidistant, meaning the segment is congruent. The converse will also be true, in which case if we start off with a triangle, you've seen this before, an isosceles triangle where two sides are congruent, then P will have to be on that perpendicular bisector. The second theorem is called the angle bisector theorem, and it's similar, it has a few differences, but it basically says that if you have an angle, in this case PQR, and you cut through that angle with QS and it bisects the angle, and you can see that right here with the congruent marks, that you've not only created two angles that are congruent, but you've got these sides, the distance from any point on this bisector perpendicular back to the side of the angle is congruent to the one on the other side. So in this case, PS would be congruent to RS. And again, the converse of that is also true. If we know these two segments are congruent and they're perpendicular to the sides of this angle, then we know that S is on the angle bisector. Okay, so let's take a look at a couple of examples of this. And the first example basically is saying, what is the length of AB? And if we look here, it's kind of hard to tell, it's a little bit lighter, but D is the midpoint. You can see the two congruent marks. And BD is also perpendicular. So therefore, B is on the perpendicular bisector. So that means that this segment AB is congruent to segment BC. So all I need to do is set the two sides equal to each other. So 6x minus 10 would have to equal 4x. And I would solve this equation for x. So we subtract 4x from both sides. So 2x minus 10 would equal 0. Then we would add 10 to both sides. Let's come up here, and 2x would equal 10. Dividing by 2 leaves us with x equals 5. Now the problem's not over. We've only found x, but we were asked to find BAB. So we want to do that. So we're going to plug 5 back into 4x. So AB is 4 times 5. So therefore AB is 20. Down here in this second example, what is the length of RM? RM is this little segment right here. And if you look, there's a congruent marks for this. These two angles are being bisected by RN. Therefore, we know that since this is perpendicular and that's perpendicular, we can say that these segments are congruent. So again, we set them equal to each other. And we will solve for x. Divide by 5, x is 5. Again, not the answer. We've got to go one more step. We have to find RM. RM is 7x. So RM is 7 times 5, or 35 would be the length of RM. And there's your notes and examples for section F2.